All righty. Okay. All right. So let's go over, let's go over about the tests and see what we can expect from the tests. Here we go. Looks good.
Yes.
All right. So in terms of the format of the test, just like the other one, the first one, we have some multiple choices and a couple of 2 or 3 problem solving. In terms of coverage of the chapter, so those are the chapters it's going to cover. So not all chapters will cover. So 4S, which is reliability, chapter 5, and then 5S, which is decision theory, then chapter 6. Okay, so those are the coverage. And in terms of those specific problems from the assignment, there will be just like those assignment, but I will change only, a few wording and then the numbers or data that we need to use.
So the other problems on those assignments, we don't need to focus on as much, just the ones you've pointed out?
Exactly. Yes.
Excellent. Okay. Thank you.
I confirm that. So just focus on these questions. Matter of fact, I have those are in summary. So here we go, starting from the reliability chapter, which is 4S. So we're trying to find the probability of the system will operate, assuming we have 2 components. So that was the assignment 4, 5, what was the number? Assignment 4, problem 1, okay? So given those probability of each component, that you need to find the system's probability, because we have 2 components, and you're going to just multiply those 2. Give me 1 second. Yeah. Did I mute it? Let me mute it. There you go. Okay. So that was A, then B, then we have a backup and switch, right? Meaning that there's a backup that you need to use, then switch will be, automatically turned on. So that's what switch does. But switch also has a reliability, okay? Whether it's 100%, 90%, depending on, okay? If it's 100%, it will be straightforward, right? Pretty much straightforward in terms of, how you're going to calculate, because this 100%, all you do is just take that reliability of that backup, then multiply by 100, which is 1. So that's pretty much straightforward, but some cases may not be 100% of that switch may work. Here's the example, the 99% reliability for that switch. Then you're going to do a little bit, well, it's basically same calculation, but you just take that particular reliability and subtract it from the main backup, which is 90%, then multiply by the component of the 2 and 1 and switch and 2 and switch for each component. So that's what we are doing, okay? So right there. So you need to subtract the other one as well. So then you're going to get the probability of 1 or backup, because you have backup with 99% reliability. Okay. So that was kind of our first question that we had. Okay. So main thing is just when you want to find components, one component or backup, then you need to take a probability of first one, which is component one, then, and you need to find when main fails and backup works, which is this calculation. So that you'll find the probability component one work or backup works. Same thing to component two or backup works. Okay. So that was the kind of a little bit tricky part if you compare to the straightforward probability, everything works in this example. And then, so that's out of reliability. What about capacity planning out of chapter 5, which is a break-even point analysis. Okay, remember we have a fixed cost, a variable cost, then we're trying to find what are the optimal quantity based on those variable. So that's the main formula we have. Okay, you have fixed costs. Then you have revenue minus variable cost. That will be denominator. Then you'll find the unit that will satisfy our break-even point. Okay, so that was the case of a company trying to build a new plant. So this plan is trying to see, how many we're going to have to produce to meet the break-even point. So given all those fixed cost and variable cost and the selling price, so that you can calculate the total revenue. Okay, so there you go. That's just copy from the spreadsheets that I had. So that's the main formula that you're going to work with, because you're going to just manipulate, because some of those questions, sub-questions, when a variable is unknown, then you're going to manipulate, then just plug in, then you find either revenue or profit, depending on the question.
Are you once again going to provide the formulas?
Oh yeah, formulas will be given. Okay, so you don't have to memorize.
Thank you.
Right. And decision theory. Remember max, and max, mean, Laplace, minimax, regret, those are the decision theory that we can use. And that's kind of traditional way of using, making decision criteria. So I guess it's a relatively, straightforward, except minimax regret. So you need to find the regret, which is opportunity costs. Right here, this is an example. So we have three different decision making, right? Do nothing, expense, subcontract. But in terms of finding regret, then you're gonna go with the highest and subtract it each cases for low and high. Then regret, again, that's the opportunity cost. So you find whatever the regret for each alternative, then you go with the lowest regret, right? So that's what they call best of the worst. Okay. So that's, I think, a little bit tricky, but other things are awfully straightforward. Okay, so that was decision theory, chapter 5S. Then out of chapter 6, which is process selection and facility, that's the diagram that we have worked with, Preston's diagram. So basically showing the number of minutes it's going to take that particular tasks so that the work flow to the right side by giving that arrow. But the main thing here is we're going to calculate this number of following tasks, meaning the task, how many tasks you have to do after your particular task. So starting from A going to H, so A will have 7 tasks to be done, right? B, from the B point, you're going to have to do 6 tasks. C, you're going to have 2 more tasks. So that's a number of, I think a little bit too small. Number of tasks, right? And the other thing is positional weight, right? Positional weight will just sum of all those number of minutes that added. Give me 1 second. There you go. So for A, task A, the remaining tasks, so you have 7 of them, you just add them up, add all those number of minutes. Same thing B, starting from task B, then you add all the weight, the remaining weights, and so forth. So you just calculate that, and that will guide you, how to put each task into particular workstation. Okay, so that's what we're going to do. So number of workstation that we need to work with, right? So, and here is our formula at this time. I think I didn't put it. Oh, here we go. Oh, that's the efficiency. Well, to find the number of workstation, and there you go, minimum number of workstation that we need to have for finishing up all these tasks, total task time, whether it's 1 hour, 2 hours, 60 minutes, and the cycle time, that time need to get a particular task. So that's how you're going to calculate. There's the total task time divided by 1.8, which is cycle time. Then it'll give you whatever the number. Then that'll kind of round up to the next integer. So that'll give you 4 station out of 3.3. So the question is how we're going to put all these tasks into each workstation, right? So that's the next question we work with. And 2 different scenarios, 2 different way of approaching it. One is using most following tasks, meaning that, see that 7, 6, 2, 2. So we're going to follow this from top to bottom, okay? If there's a tie break, like here, 2, 2, 2, so there's a tie break. If there's tie break for particular tasks, then we go with higher positional weight, which is 2.3 in this example. So we have a 1.6, 2.2, 2.3 for 2 following tasks. So we want to go with 2.3 because it has a higher positional weight. So that's how we're going to approach, this way, using most following tasks. Then if there's tie, then we're going to go with higher positional weight. So that's why we have it here. So to satisfy, in this example, each workstation you need to have 1.8 minutes. Okay, that's the cycle time. So to make it 1.8 minutes efficient, and we're going to assign whatever task into each station. So that's what we have in this first table. Then the second type, the the second type of assigning those tasks, we're going to just go with the greater positional weight in that order, right? So remember those positional weight that we're going to take from the highest, next highest, and so forth. So that's what we're going to go with. If there's a tie on positional weight, then we're going to go with the next higher following tasks. So that's what this method will do. And if you do that, then I think it's almost same because we have only 7 tasks. So it's just, you'll have a very much same results based on this, this question. So that's the order for second method. Workstation 1, you have a task 1. Workstation 2, you have task B and E and D, C, F, and G, H. If you look at this one, I think it's identical. Yeah, it's identical in terms of the result we are getting. Unless we have a dramatic, number changes. For example, those number of minutes are very similar in this example because it's 0.5, 0.6, 0.5. So very little changes. So even though you're using different method, the result were very much same. Then the last one we have is last question out of this scenario is what's the efficiency? Whether we are using well the time so that we don't have too much idle time, right? So that's the efficiency. So total number of tasks time, which is 60 minutes, then divide by number of station, then cycle time 1.8, then we have 0.83. So 83% time we are kind of, working on the task rather than having break or idle or waiting for something from the other workstation. So that's the efficiency. So that's what we're going to expect from the tests. Of course, it's not all show up, probably 2 or 3 different questions. Okay, any question? Any question at all? We good?
No, just
No,
scared.
thank you.
That's a lot.
I know, yeah.
Yeah.
Well, like I said, I'm trying to, I'll try to align very much like the assignment so that there'll be, as little confusion as possible.
Thank you.
All right. Okay, so good luck. All right.
Off to studying. Thank you.
All right.
Thank you.
Take care.
Thanks. Bye.
You as well.
Bye-bye.
Thank you.